Hello everyone, welcome to the Mathematics MI channel. In this video, we are going to solve another interesting integral. Integral from minus infinity to infinity, x times e to the x minus a times e to the bx dx. Okay, let's start with a substitution. So, I am going to take this part is equal to t. So, a times e to the bx is equal to t. Then we need to dx. So, we can differentiate. So, we can write a times b e to the bx dx is equal to dt. Then here a times b. Now, e to the bx, we know e to the bx is equal to t over a. So, here t over a dx is equal to dt. Then we know this a get cancelled and we can isolate the dx is equal to dt over b times t. Well, then here we need to x and e to the x. So, we know e to the bx is equal to a times e to the bx is equal to t. So, we can isolate the e to the bx. E to the bx is equal to t over a. Then we know e to the x is equal to t over a raised to the 1 over b power, and also here we can isolate the x. So, I am going to take natural log both sides. So, bx is equal to natural log t over a. Then we know x is equal to 1 over b times natural log of t over a. Okay, then we can plug in here. We know lower limit when x approaches to minus infinity, t approaches to 0. Also upper limit x approaches to infinity, t approaches to also infinity. Then here we have x we know 1 over b natural log of t over a. Then e to the x, here we have e to the x we know t over a raised to the 1 over b times. Then here we have e to the e to the minus a e bx we know minus t. So, e to the minus t times now dx we know dt over b times t. Well, then we can simplify. We can take constant outside of the integral sign. So, here we have b, here b. So, 1 over b square, and here we have a to the 1 over b. So, 1 over a raised to the 1 over b, integral from 0 to infinity. Now, here we have e to the minus t times t to the, here t to the 1 over b, and here we have t. So, we know t to the 1 over b minus 1 times now natural log of t over a. According to property of natural log, we can write natural log of t minus natural log of a. Then here dt. Okay, then we can write our integral into two separate integrals. So, we can write here 1 over b square times 1 over a raised to the 1 over b times now here integral from 0 to infinity e to the minus t times t to the 1 over b minus 1 times natural log of t dt. Then minus, here we have natural log of a constant. So, natural log of a integral from 0 to infinity e to the minus t times t to the 1 over b minus 1 dt. Okay, then I'm going to recall the definition of gamma function. We know gamma of n is equal to integral from 0 to infinity e to the minus x times x to the n minus 1 dx, and now I am going to take a substitution. X is equal to k times y, so dx is equal to k times dy. Now we can write here gamma of n is equal to limit also 0 to infinity, here e to the minus x, x we know k times y, and here x we know k times y, so we have ky raised to the n minus 1 dx is equal to k times dy. Now we know here we have k to the n minus 1 power, here k, so we know k to the n we know constant, so we can take outside denominator sign. Also we can write k to the n, here gamma of n over k to the n is equal to integral from 0 to infinity e to the minus k times y to the n minus 1 times dy. Okay, then we know definite integral independent of the variable, so instead of y we can use x, so we can write gamma of n over k to the n is equal to integral from 0 to infinity e to the minus kx times x to the n minus 1 dx. Now I am going to differentiate with respect to n, so here we know here we have k to the n raised to the 2 power, so k raised to the 2n quotient rule, so here k to the n. Now derivative of gamma function, so gamma dash of n minus rewrite gamma function gamma of n, then derivative of k to the n we know k to the n times natural log of k is equal to this side integral from 0 to infinity e to the minus kx x to the n minus 1 times natural log of k, sorry here not k, here x dx. Okay, then I am going to plug in 1 for k, so when k is equal to 1 we have here gamma dash of n, here we know this is equal to 0, and here integral from 0 to infinity e to the minus kx x to the n minus 1 times natural log of x dx. Our integral here 1 over b square 1 over b square 1 over a raised to the 1 over b, so we can write now 1 over b square a raised to the 1 over b times now here we know this integral is equal to gamma dash of n, so here we have gamma dash of 1 over b, so we can write gamma dash of 1 over b, then here we know minus natural log of a times here this is we know the definition of gamma function, so gamma of 1 over b, so we can write here gamma of 1 over b. Now I am going to take the gamma of 1 over b as a common factor, so gamma of 1 over b over b square times a raised to the 1 over b, here we have gamma dash of 1 over b over gamma of 1 over b minus natural log of a. Okay, then gamma of 1 over b over b square times a raised to the 1 over b times, now in a previous video about digamma function video we talk about digamma of x is equal to gamma dash of x over gamma of x. So here we know we have digamma of 1 over b minus natural log of e. Okay, this is the answer. If you like this type of videos, please subscribe this channel. Thank you for watching.